This movie presents a methodology, used in the development of the SCADA ActionNET, which greatly reduces the time of development and implementation of an application, as well as increases its quality and minimizes the possibility of errors. In addition, it maintains knowledge of the deployment process within the software, and not only the technicians who participated in the enterprise. Let's create a substation called Substation 1, using the component substation.component, created by Spin, based on a standard of 1 utility. Once the ActionNET configurator is activated, we create a new project, clicking on New Project, and enter its name, Substation 1. And its model, defined by the number of communication points supported. An empty default new project will be loaded. And once opened, we go to the Run component, and import the substation component. This import action takes a few minutes. Once we are importing more than 2,500 objects that correspond to all the templates of the supported base of distribution, all screens, all command windows, all scripts, all symbol libraries, etc. In the templates of each bay, since we are considering a substation, with relays using the IEC 61850 protocol, for each point in a bay, there is its IEC 61850 address, generated according to the standard, the alarms and events it should generate. Each time do you import a component, in Run, Build, do a project build, to see if there are conflicts between objects of the original project and the imported component. Before we continue with the substation configuration, let's take a look at the project content after importing the component. The objects that we will see are the ones presented here. Let's go. In tag/objects, references were created for all types of bays of the example, and the definition of a feeder bay was created with the name SPF_11F1. To define the substation bays, just copy this line and paste it, changing the attributes. Let's navigate to the feeder template. The first template is the same to all bays. It has 4 groups of tags: protection, status, command, and measures. Each one of them is a subtemplate. Let's navigate to the protection subtemplate and see its content. The protection submodel has, for each line, an input or output or calculated point. The points have several parameters, which will describe the application's behavior, depending on values change. Various parameters will be used in the automatic generation of the tables of alarm, history, and points. After a bay type has been tested, all bays of the same type have also been tested, since the difference between them are only their IP address. At the Assets folder, as you can see, was created the hierarchical tree of the substation, where each leaf is one type bay. Each display line is a screen or window of the application. As you can see, there are several screens and windows already ready. If we double-click on any line, we navigate to the respective draw screen. The first example is a command window, and the next 2 are type bay detail screens. In the script folder, we have scripts associated with screen actions, like screen open or close, mouse click, mouse position, etc. Going to scripts, you can develop scripts or classes, using C#, VB.NET or Python. You can also develop logical expressions. One double-click on a task or class navigates to the respective code and code editor. You can compile and debug the tasks or classes. At security, we have pre-created users, with their associated permissions and policies, as well as an area for dynamic user creation. At alarms, we have a predefined group of alarms. The attributes of each one describe its behavior. Finally, at datasets, we have 5 predefined tables, using the native SQLite database. Completing this step, when we import the substation component, we import all the necessary structure to generate a substation, with the supported bays. Depending on the substation size, we will be able to generate it in a few dozen minutes, or in a few hours, no more. If the component is already tested, there will be no errors, and the quality of the solution will be optimal. Now, let's create our substation. As said previously, we have bays reference imported from the component. We also have a line example of how to declare a bay, the feeder SPF11F1. Using the rules defined in the movie, we will create one line for each bay of our substation. Let's do it. To create new bays, starting from the existing one, just copy and paste it in the new line, changing 7 attributes. Its name, type, node and address prefix, level, category, and, finally, its description. As you can see, we spent a few minutes creating 6 bays. Now, let's create the channels and nodes. We have 6 IEDs, 1 for each bay. All of them are IEC 61850. We will create here the first channels for the feeders 11F1. We can do it using create channel, where we standardize that the channel name will be its own identification. To exemplify, however, instead of using create channel, let's copy the identification of the channels from an Excel spreadsheet created previously. You just copy from the spreadsheet and paste it in the selected area. Adjust the name of the channel, that should be the same as its description. The parameters associated with the channel are correct. Next, we will create the nodes associated with the 6 channels in a similar way, that is, copying from the Excel spreadsheet and pasting in the highlighted area of nodes. In the nodes attributes goes the IP and port that identifies the respective relay. As the 11F1 feeder will be simulated on the machine, we use the IP showed that defines the own computer. After the creation of the channels and nodes, before running the deploy extension, which generates alarms, history, and I/O points, we will show the empty tables. Now, let's go to the extensions, select the 3 options, and run the deploy. At the deploy end, 1,547 tags were created, associated with the 6 bays of the substation. The alarm table has 834 items. The I/O points table has 589 points. The historian table has 124 registers. And the substation's hierarchical tree has the 6 created bays as leaves. The next step is to create the screen with the substation's single line diagram. In Tags, Objects, we select the 6 bays just created, copy them, and paste them in a screen of draw section. The bay objects are transformed into the respective symbols. We positioned these according to the single line diagram. A double click on the bay shows its window, with its name and the name of the associated bay, as can be seen. The first bay shown is the 11F1 feeder, and the second, the 11F2 feeder. And we finished. Our substation is set up and ready to be tested. See the project running in the next video.